Hey guys, this is lesson 11's video, and in lesson 11, we are going to be identifying what evidence can support a claim or claims. We'll look at an online simulation and compare the properties of gases and the properties of liquids. So, the first thing we could look at we're going to be looking at how we can use the evidence that we have collected over the last few lessons and match it to a claim that it would support the best. So we could make two claims about our original cold cup. One, that heat is entering the cup system, or we could say that two, cold is leaving the cup system. So this is in reference to the original plastic cup with cold water, a lid, and a straw, and that the cold water heats up over time. So that could be because of one, heat entering the cup system, or two, cold is leaving the cup system. So we have evidence that we have gathered over the last few lessons that could support one, both, or none of the claims. So after I go through the evidence that we have collected, you will have three questions that will bring up each claim, and you will decide which pieces of which pieces of evidence support the claim, so you might have a piece of evidence that could support one claim only. It could support both claims, or it might support none of the claims. Okay, so the first piece of evidence is the peppermint dye video from earlier this week. That was the one with peppermint candies in the saucers of different temperature water. The peppermint dye spread through the hot water faster than it spread through cold water. That was the evidence from that. We also have evidence from the water bath lab. So this is when we were placing containers of different temperature into larger containers. So this is when we put for example, we put a cup of cold water placed in a container of hot water and left it for a while, and the cold water warmed up and the hot water cooled down. And then we read about James Joule's experiment, and that's where he discovered that spinning water very fast caused the water to heat up. Now, if you were in school Monday, November 30th, you got to see the food coloring lab or the demonstration. If you were not here, that was at the end of the video, and I gave you the instructions, and you had the option of doing the food coloring lab. But our conclusions from that is that we saw that the food coloring spread through the hot water faster than it was able to spread through the cold water. So you will have three. You'll have claim one. I'll bring claim one, claim two, and the other options up in the questions. And so you'll use these four pieces of evidence if it supports that heat is entering the cup system, then you will just put the name of the different pieces of evidence that go with that claim. So these pieces of evidence, they might support one claim, they might support both claims, or maybe they don't really support either one at all. Okay, so now we're ready for particle simulation. And I found a simulation that shows how particles are moving in cold, hot, and warm water. And as I play the simulation, jot down your notices and wonders. And you'll know that the next question after I play the simulation, the next question will be asking for at least 3 notices and 1 wonder. So you might grab a little sheet of paper, something handy to jot things down as you watch the particle simulation. So let's open that up. So here is our particle simulation. And so we're going to keep the simulation on cold. So right now, these are particles. So this is a glass of water here. Zoomed in, these are the individual particles of water. Those gray spots are individual particles of water. And so this would be the particle motion and arrangement for cold. So take a moment to record any notices and wonders you might have about the particles of cold water. Okay, so now I'm going to move the slide bar down here from cold over to hot, and let's observe what happens to the particle motion and the particle arrangement. So those are particles of hot water. What do you notice and what do you wonder? So now we're going to slide the bar to the middle, which would be the warm setting, and record your notices and wonders. So I'm going to slide it right to the middle. So that would be the warm water. What do you notice and what do you wonder? Now I'm going to do one more thing. I'm going to start it all the way back over here at hot. And now watch what happens to the particles as I move it from hot to cold and then move it from cold back to hot. Okay, now I'm going to move it from cold. I'm going to go back to hot. Okay. So now you are going to list at least 3 notices and 1 wonder you had about that simulation. So just a reminder, you learned about this last year, that kinetic energy is the energy of movement, or how fast or slow particles move. We would say that those particles have kinetic energy. So if they have fast movement, they would have a lot of kinetic energy. If they are slower moving, they would have less kinetic energy. So, based on using this information and reminder of what kinetic energy is, there are 2 questions about the simulation you just watched. So, answer the 2 questions about the simulation you just watched of the different temperature particles. So, air particle movement. Now we know that liquid particles move around freely at different speeds. We've also figured out that particles in a cold liquid move slower and those in a hot liquid move faster. So let's consider gases. So think about the following things. Do gas particles move around like liquids? So things like air. Air is a gas. Do those have movements that remind us of how liquids move? And the answer to that is yes. They can slip, they can move past each other freely, and they can take up space like liquid does. Since gas particles move around freely like liquid particles can, what can we expect if we were to spray perfume or some other strongly scented oil on one side of the room? So try it. So try it yourself and see what happens. So spray some perfume or air freshener or room freshener or some strongly scented oil on one side of the room. Walk to the other side of the room and wait. Can you eventually smell it across the room? You can pause the video here to actually go try that. And then there are 3 more questions. After you've done that, there are 3 more questions to answer about in this Ed puzzle.